In today's video, we're going to be confirming or rejecting equal variances in Python with the help of Levene's test. This video is going to go over 3 different Python examples. The first one being a manual calculation, and then the next 2 utilizing SciPy to make our lives easier with examples with 2 and 3 groups. But before I jump into the Python code, I want to go over a little bit more background information about Levene's test and some of its applications. All right, so let's talk about Levene's test. So first, why do we need Levene's test? Well, we need it in a few different use cases. If we're looking at independent 2-sample t-test, or if we're using an approach like ANOVA, it works with non-normal data. And what it allows us to do is to confirm or reject equal variance. What also you should know is you can use Levene's test with 2 or more groups. So there's a few different types of Levene's test out there. So you can use it with the mean, you can use it with the median, which if you use it with the median, you'll also hear this called the Brown-Forsythe test. And you can base it off of the trimmed mean. In SciPy, you're allowed to use all 3 versions. Just use your parameter in there and say if you want to use the mean or median. Although I will mention that the mean is the most common version, but in this video, we'll be going over the mean and median. So what you'll see for the null hypothesis and alternative hypothesis in this is the null hypothesis states that all the group variances are equal, and the alternative hypothesis states at least one group has a different variance. Typically, you're going to see a significance level of 0.05. All right, so here is the formula. We're going to go through an example calculation because it looks quite confusing at first glance. And there's a lot of work that is involved to getting the calculation. SciPy makes it really easy, to be honest, on the Python side of things. But let's go through a example over here. This W also, I should mention, is going to be equal to your F statistic. But yeah, let's jump through. So first step is going to determine our null and alternative hypothesis. Then we're going to find each group's mean or median, depending which route you want to go. Then you want to calculate the absolute deviations from the mean or median, calculate the mean of the absolute deviations, calculate the sum of the square deviations, find your degrees of freedom, perform Levene's test calculation, find the p-value, compare it, and then make a conclusion. Yeah, 10 steps, quite a bit. And well, let's go through our manual calculation. So let's take a look at this example, right? We have ticket sales data for 2 bands. We have Slayer and Metallica for several concerts, and we want to check if the variance in the number of tickets sold is the same for both bands. We're going to do the default significance level of 0.05. Here's our data, and this is going to be in thousands of tickets. So Slayer 2018, 22, 19, and 21. Metallica 28, 30, 27, 29, and 31. All right, so I'm going to go through this example of the median just because it's a little bit faster to calculate. And again, don't worry, we'll be going over some mean examples as well. So first thing, state the hypothesis, right? So null, the variances of ticket sales are equal for Slayer and Metallica. Alternative, the variances of ticket sales are not equal. Then calculate the medians. Slayer is 20, Metallica is 29. Then we want to calculate the absolute deviations from the median. So here's how we do this, right? You have 20 minus 20, you take the absolute value of that, and you have 0. Now you have 18 minus 20. We're just going down the list, right? Subtracting our value from the median for each of these and then taking the absolute value. So you see Slayer, I did all of those, and then Metallica. It was much easier just to show you guys like this than it is one by one, right? So calculation, absolute value, calculation, absolute value, across the board are absolute deviations. Okay, now what we're going to take a look at is calculate the means of the absolute deviations. So we have 0 plus 2 plus 2 plus 1 plus 5 divided by 5. We have 1.2 is the difference, right? Just going back over here, summed all these up, and I divided by 5, right? And did that for both Slayer and Metallica. They were both 1.2. Now we want to find the overall mean. So 1.2 times 5, 1.2 times 5 divided by 10, 1.2. And then this is going to be our numerator calculation, right? So we're going to take 5 times 1.2 minus 1.2, right? Let's say we have Slayer minus this overall mean, we square it, right? And then we do the same with Metallica. 5 times 1.2 minus 1.2 over there. and the numerator is going to be 0. Now, technically, right, we could stop there for our calculation because this is all multiplied, right? You have 0 over here. It doesn't matter what it's over here. As long as the bottom's not 0, our final answer for W is going to be 0. But I'm still going to go through this just to show you guys all of that, right? But I just wanted to call that out. Okay, so step 5 is calculate the sum of the squared deviations. So what we do down over here, right, is 0 minus 1.2, we square. 2 minus 1.2 square. 2 minus 1.2 square. 1 minus 1.2 square it. 1 minus 1.2 square it. And we have the square deviations over here for both Slayer and Metallica, right? So again, the absolute deviations, we take the absolute deviations and then we subtract out 1.2 because that's Slayer, right? 1.2 from Metallica, and just go across. Now we have 2.8 for each of these. We're going to add these together for our calculation. You can see this here at the bottom, and it's going to be 5.6. All right. Now we're going to find our degrees of freedom, which is also part of this formula. So you can see the n minus k and then the k minus 1 over here. So let's find our value of n. N is going to be 5 plus 5. Each had 5 observations, so our n value is 10. K is these different groups, right? So 1 and 1, k is going to be equal to 2. So df between, which is going to be k minus 1. 2 minus 1 is 1. df within, n minus k, that is going to be 10 minus 2, which is going to be 8. Awesome. So now we perform Levene's test calculation. So we have the sum of the absolute deviations, 5.6. The numerator calc is going to be 0. So all we do over here is we take 8 times 0, right? And then we have 1 times 5.6, which is this down over here. And we get a final W value of 0. Now what we have to do is find our p-value. And we find our p-value is going to be 1. Which confirms that there's no significant difference in variances between Slayer and Metallica ticket sales. Thus, we failed to reject the null hypothesis, include the variances are equal. And I ran this for both median and mean for this example, and they both come to the same conclusion that there's no difference in the variances between the Slayer and Metallica ticket sales. So we're going to jump into some Python code. Our first example is going to be sort of manual like this, but then we're going to jump into some other examples that literally just take a few lines of code, simplifies the process a ton. But I wanted to show you guys this so you would appreciate what SciPy really does for us and makes our lives so much easier. All right, grab your notebook and let's start coding. All right, let's get started. So what we're going to say is import scipy.stats as stats, import numpy as np. Then what we're going to do is set our alpha value for the whole video. I'm just going to say it's equal to 0.05. Run that and let's get going. So we're going to start with example 1. And for example 1, what we're going to do is we're going to take a look at 100-meter race times for college and pro athletes. All right. So what we're going to say is college times equals 10.5, 10.7, 10.8, 10.4, and 10.6. And what I'll have for pro times equal 9.9, 9.8, 9.7, 10, and also 9.9. Fix that there. 7, 10, and 9. All right. So, great. And what we're going to do is we're going to calculate the means on this one. So calc the means. So let's start with that. So say college mean equals np.mean. Pass in our college times. And then we can do the same for pro. So we'll have pro mean, and we'll just pass in pro times. All right. And if you want to see what these look like, just print out our college mean, which will be 10.6. Print out our pro mean, which will be 9.86. Awesome. Now what we're going to do is we're going to calculate the absolute deviations. So let's start with that. So we'll go college. So college abs deviations equals np.abs. Oops. Abs. We'll have college times minus college mean. And we can print that out as well, just to show you guys where we're at. Right. So that there. Then what we can do is do our pro. So pro, and then just change college to pro for each of these over here. All right, we can print that out also. Here are those. Now what we want to do is calculate the mean for each of these. So calc mean absolute deviations, and let's get going with that. So we'll say college mean deviations equals np.mean. Pass in our deviations. So we have that over here. Well, college is here. Right. Print that out. 0.119. And then we'll do pro. So pro. Print that out as well over here. 0.0879 repeated. Then what we're going to do is calculate the sum of the squares. So calc sum of squared deviations. And we'll start off with college. So college squared deviations equals np.sum. And inside over here, we'll have college absolute deviations minus college mean deviations. Then we're going to square that. Right, run that. And then we'll do the same thing for pro. So just change all these colleges to pro. Right, pro there, pro here, pro here. And that's, you can print these out too. So print college 0.028. Print out our pro 0.013. Now let's find our total. So let's say total squared deviations. So just sum these up. So total squared deviations equals, and we're going to add in our college and pro. So college plus pro over here. Awesome. Then now we need to get the total observations. So we'll get total observations, and that's going to say n equals length of college times plus length of pro times. Perfect. Then get our k value, and our k value is going to be k equals 2, right? Because we have two groups on the side, the college times and the pro times. And now we can calculate our degrees of freedom. So degrees of freedom, and we'll say df between equals k minus 1. And man, I'm so used to df being data frame, but also df for degrees of freedom. Df within equals n minus k. We can print these out if you want. Right, we have one there. print, this lines up with our example, right? Being 1 and 8. All right, and still more work to do. What we're going to do now is the between group sum of squares. Actually calculated our degrees of freedom a little bit early, but that's all right. All right, so we're going to say z grand mean equals np.mean, np concatenate over here. We'll have college absolute deviations, and then pro absolute deviations. Hopefully that works there. Awesome. Then what we'll have to do is we'll sum of squares. Sum squares between equals the length of college times times, and then over here we'll have college mean deviations minus our z grand mean that we have over here. We're going to square that, and then we're going to plus, and we're going to do the same thing this time for our pros. So pro minus z grand mean times 2, and we also need to multiply that length. So let me just double check over here. Length college times, that's what we needed to change. Pro times. All right, and to just print that out. Print out both of these. Show you what the values are. Very, very small value there. And print our overall there. So 0.103. Perfect, perfect. And now we're going to calculate our W, or also known as your F statistics. So calculate formula. All right, and now the calculator formula, we're going to say W equals, and we'll have DF within times sum squared between, and that is all going to be divided by our DF between times our total squared deviations. All right, and then we can print out our W value. You get 0.496, but this isn't final because we need to find our p-value now. So we're going to say find p-value. And to find our p-value, we're going to say p-value manual. It's going to be equal to 1 minus f, or stats.f.cdf. And then we're going to pass in here is our W value, then DF between, and DF within. Right. And finally, let's print out. So print out our p-value manual. And we get 0.5. And one last thing, we're going to have to analyze our p-value. So we'll say analyze p-value. And let's just write a basic if-else statement. So we'll say if p-value manual is less than our alpha, right? So print reject null hypothesis. Man, that was terrible spelling. Hypothesis, and we'll say different variances. And no need for that colon there. So, well, that's else print fail to, I'm just going to say similar. Well, it's similar or same. So we'll say same variances. And we go this, we fail to reject, right? We have a very high p-value at 0.5. Our alpha is 0.05. So we fail to reject, right? the variances are quite similar between our college and professional runners. So that was the manual way. Like I said, a lot of work. You guys saw that without even using Python, but still, even with Python, there was a ton of code. Now, let's take a look at our example, the Slayer and Metallica ticket sales. But what we're going to do is we're going to shorten this a ton. So we'll say example two, Slayer versus Metallica ticket sales. And we'll have Slayer sales equals, and I'm just going to pass in those numbers that we used on the slides. And we'll have Metallica sales, sales equal, and same thing. Now, instead of all of this code that I wrote, right? Check how easy this is. All we got to do is we'll get our test statistic or our W value, and then we'll also get our P value. And all I have to do is stats.Levene, and then pass in our Slayer sales, pass in our Metallica sales, and then we set our center. So this time we're going to say center equals median. Again, you can change this. You could say mean. We'll go in that example 3. But now, just to confirm what we got, right? Let's print our W first. So print W, and you see it's 0, like we had in the example, right? And then we can print our P value, and you'll see our P value is 1, right? And we could literally just copy and paste this over here. And again, we don't need this. We already know, like, we fail to reject our null hypothesis, but we want to fail to reject null hypothesis, same variances. So example 3, we're going to change this up a little bit, and we're going to still use ticket sales, but this time, so example 3, we're going to look at 3 bands. I should make this different. So 3 bands looking at the mean, right? So here's how we could do that. I have 3 different bands. So we have Gojira, and they're probably all about the same size. So we have Gojira over here. We have Mastodon. And then the third one, which I still want to see live, but they barely toured the US, is Opeth, right? So 3 metal bands, Gojira, Mastodon, Opeth. These are their ticket sales. Gojira is really popular right now. They just had a performance at the Olympics that people love. So let's assume they sold 7,000, 11,000, 2,500, 9,000, and 3,000 tickets. Mastodon, 3,000, 4,000, 1,500, 4,000, and 2,000. And then Opeth at 2,000, 1,000, 2,500, 3,000, and 1,500. All right. And now let's find our values. So a little bit different, right? This time we have 3, but all we have to do is W, and we'll say P value, and it's going to be literally almost the same code. We'll say stats.Levene in here, and then let's pass in all 3 of these, right? So we have Gojira sales first, so Gojira sales, then we have Mastodon sales, and then we'll pass in Opeth sales. So literally all we have to do is pass in our third group, right, our Opeth, and then we'll set our center. So center equals mean, and that's the default parameter, but I highly recommend you just put your center and specify that there, so there's no confusion when someone reads over the code. All right, so we have center mean on here, and now what we can do is print out our W, and the W in this case is 8.732, and then print out our P value, and the P value in this case is going to be 0.004, which our alpha is 0.05. So this is awesome, right? We can just go over here and grab this and reject null hypothesis, different variances. And that's it for the code side of things, right? We went through this pretty tedious manual example first, right? And if you skipped ahead, I don't blame you. But then we went to SciPy, and literally, like, it's just a line of code, and we get our P value, we get our W value, and we can pass in multiple groups, right? This example, Metallica and Slayer, you can specify your center. And this one, we passed in 3, Gojira, Mastodon, Opeth. We changed the center to meaning, and we changed the center to mean, and we got our W value and our p value. And just remember, our w value is going to be our f statistics. Our w value is going to be our f statistic. And yeah, that's it for Levene's test. You'll be seeing this in other videos that I'm going to be producing in the stats series. So make sure you got a grasp of this before moving on in this playlist. And hope you guys enjoyed. Well, that's it for Levene's test. Thank God for SciPy and Python, because it makes these calculations easy, but it'd be a bit tedious without it. And if you were able to learn something new, make sure to subscribe to the channel. One of our goals is to reach about 100,000 subscribers in 2025, and we have a very long ways to go. But to make it there, we're going to upload at least 3 videos every single week. And if you want to learn even more about statistics, I have a few videos linked down below in a playlist right over here. And the playlist will have more applications of Levene's test within future videos.